Well, welcome to week 11. We're almost done. Um, just one more topic after this one, set of topics, I should say, and then onwards. You should check Access to double check when your exams are. It's showing up in my timetable on Access, which means it should be showing up for you guys. Currently, according to Access, it's scheduled for April 17th. I think it's 6 o'clock at night. I think I noticed it was 1800, but I will confirm that and put it in the announcement. Okay. So today's topic is set operations. It's a fairly straightforward concept. Um, how many of you remember doing sets in school? You know, got data set A, data set B, and then you do the math. Yeah, that's exactly it. See, Canadian students are going, no, I didn't learn that. International students are going, yeah, I learned that. Goes to show you how our math scores are so bad in Canada. Not picking on the Canadian students, but the few in this room. Yeah, pretty much. I remember taking it in grade 7. So, yeah. No. This was something they used to teach in grade school. And then they approached it in high school with much more advanced, but they used to teach it in grade school. Okay. So, set theory, which is actually one of the foundational things of database, even though it really isn't taught that much, is the concept of taking two similar data sets and figuring out the overlap and or not overlap between them. Um, the good news is that MariaDB and now the most recent versions of MySQL support all the set operations. Until about 2 years ago, MySQL didn't support two of the three because it's backwards. Postgres has had it for 20 years. Oracle and Microsoft SQL Server has also had it for a long time. So if you remember when I was talking about joins, about how often they use Venn diagrams to describe joins, which I always say is the wrong way because joins are not Venn diagrams. Set operations are literally Venn diagrams. And thinking of that, when I went to college, they decided to give us a review on set operations in our math class. We did Venn diagrams. So you guys know what a Venn diagram is, right? For the most part, you got two circles. Yeah. So maybe they didn't call it sets. Maybe they just called it Venn diagrams, right? Hey? Of course not. So you got set A and set B. Now, when you have three set operations, union, intersect, and except. Database introduces one extra one called union all. And I will explain union all in like one line. It just gives you everything from both sets. So the first one that's been supported in pretty much everything since day one is union. Basically, what union does, it's everything from A. Well, not quite. It's everything from A plus anything from B that is not in A. So yes, it gives you everything, but it only gives you the unique values of the two sets put together. So union says, give me everything from A plus anything from B that wasn't already in A. So I put up a database on the announcement. It's very basic. We have two tables in it, clients and booth visits. Has anybody here ever gone to a trade show of any kind? Or you go to like an exhibit of some sort where you can actually tap your visitor's badge to get more information about the products that they've got there. So a lot of industry trade shows, when you sign up at the front door, they give you a visitor's badge, right? And as you visit the booth, they often have a little machine by the booth you can tap, and it adds your contact information to that company saying, I'm interested in your products, include me in your spam. This is what this is emulating. So you have the clients, which is basically a list of clients that belong at a company. And then we have the booth visits, which is a list of people that visited a booth. This is really important information in the business world, even though this is super simplified compared to how it normally would be done. However, when you run a trade booth, it costs a lot of money. You got to rent the space, you got to bring the equipment, you got to pay the people to go, pay the flights, all that fun stuff, all the marketing material, and all the crap. So you want to know demographics. How many people visited your booth that were already customers? How many people that visited your booth are not customers? Stuff like that. So what Union allows you to do is, let's say I want to send out a mailer and I want to send it to everybody, my customers plus anybody that came to a booth. So I am going to go select email from clients. Okay, that's pretty basic SQL. And hang on here, I got to go connect to the right database. There we go. So I run this. Wow, amazing. It's a piece of SQL. I can also go select email from booth visits. Here's my emails from my booth visit. Now, I could decide to just create a mailer that sends to all the clients and all the booth visits, but there are some laws that say you're supposed to avoid sending the same email to the same person multiple times. North America, those laws pretty much get ignored. In Europe, it can cost your company a lot of money. So what you want to do is you'll do a union. So if I go back to my results, my clients have 200 rows and I had 63 visits, booth visits. So I have a total of 263 rows between the two tables combined. If I do a union, I get 240 rows. So if I do 263 minus 240, that means I have 23 existing clients that visited my booth out of the 63 people. That's important in statistics. Um, and that way, each person only gets one email. It's also for a lot of mail services like SendGrid or Sendinblue, MailChimp, that kind of stuff. They charge you per email you send out, or they charge you per how many clients you have in your database, plus how many emails you send out. So therefore, it behooves you to not have a lot of duplicates because you're paying for nothing. The good news is a lot of these services also support a deduplication service, but why deduplicate if you don't have to? All right, so this basically grabbed all emails from clients plus any emails from booth visit that wasn't in clients. So it's everything, but the unique version of everything. Now here's a spot where I'm going to highlight a few peculiarities. Why can I never say that word? A few quirks of working with set operations. This will fail. Why? Because the sets are not similar. I didn't say identical. They're not similar. In other words, they do not have the same number of data points. One has two, one has one. Therefore, you can't compare sets when they don't have the same number of elements. The other thing that is touchy, and let's go find out if my MariaDB, okay, MariaDB is stupid. As you notice, it returned 263 rows because it all goes there. Other database servers also require you to have the same data types because you can't compare an integer to a string because they're not the same thing, right? It's just like when you're working in Python or JavaScript. Actually, no, JavaScript's stupid. Actually, Python is stupid too. So Java, C++, C Sharp. The reason I'm saying they're stupid, I'm a PHP developer, so PHP's stupid too. So I'm not just shitting on those languages. Python, JavaScript, PHP are typeless. So it will coerce data types on the fly or cast data types. So you feed it a string, you feed an integer, it'll go, oh, they're not the same. Well, we'll make the integer a string, then we'll compare. It'll just do it for you, which is not great. Unless you force, you do a identical operator, like in PHP, it's 3 equal signs as opposed to 2 equal signs. Um, if you're doing this comparison in C++ and C and Java, C Sharp, it'll look at these sets and say, hey, one of these is a string, one is an integer. I can't do that compare today. TFB, we're done playing now. Go home. So when you do, and in actual fact, I'm kind of concerned about the fact that it allowed that. Let me go see. Say, look, there's the names, and now the ones that have the IDs is the ones coming from the second table. So it literally just went, yeah, that's cool. So the rule when you're working with set operations is same number of columns, same data types, and this is a database design terminology, same domain. Not domain as in an internet domain. In this case, when we say a domain, we're talking about it's the same kind of data. In other words, you wouldn't compare email addresses to phone numbers. You wouldn't compare email addresses to people's names because it's not the same kind of data. So when you do set operations, you want to operate with the same number of columns, the same data types, and the same data domain. Once you get that, everything's gravy. Now I'm going to take this query and make it a union all. And this returns 263 rows. Literally union all says do a union, but give me everything. Which is kind of defeated. You might as well just sent out 2 queries at that point. All right, so that's the union, is all of that. Now, the next flavor that we will see, I'm going to make my circle smaller so I stay in camera, is the intersect. Oops. Intersect is where the 2 data sets overlap. So essentially, I want the email addresses for only those that exist in both databases. So we already established that we should have, what was it, 23? So if we take our query and go show you how simple set operations are, just change the keyword and we run it, there's our 23 rows where this is our clients that visited our booth. Sometimes we might want to do a promotion for our clients that came to see us at a booth, say, hey, you're a very loyal customer, have an extra 10% off your next purchase and give them a coupon. But we don't want to give that 10% off to everybody. We just want to give it to the ones that are, extra loyal. And that way you could pull out an email address list of just those 23 people that have bought your product in the past and took the time to come and see you at the trade show. Because depending what industry you're in, the odds of having 23 of your customers in the same city where your trade show is might be pretty small. I mean, I'm using really small numbers here. But if you're looking at like the sign making industry, the niche is small. Like even in Ottawa, city of 1 million people, which, depending where you're from in the world, 1 million is not very big, but in Canada, it's a solidly sized city. I think there might be 50 sign makers in Ottawa, 50, 60 sign makers total in Ottawa. So, like the company I used to work for before I joined working for the government, they worked in the sign industry, and we had a very big chunk of the market. So we controlled like over 40, 50% of the market was just ours. In the different platforms. Actually, for some, depending which market you're talking about, like which platform you're talking about, we had more than 40%. And they could go to a trade show, and at a trade show, they might have seen 300 clients. Out of those 300 clients, maybe 5 are from the same city. They were coming in from out of state. Therefore, people that are already your customers from out of state or out of province, you might want to give them an extra reward. And that's what the intersect will do for you. You'll get that list and it returns it. Now, we can go to the next stage after that, which is accept. Um, Depending which database server you're talking about, this also known as a minus or a, is it the difference? I think it is. Yeah, what's the minus, the subtraction. So what accept does is we've got our two sets again, A and B, like that. However, it will give you everything from A except any you find in B. So it'll only give you everything in A that is not in B. So we just want to find all the clients that never came to the trade show, right? Send out the guilt email saying, we had a trade show and you guys never even bothered to come see us. And you think companies don't do that? They absolutely do it. Because nothing is out of bounds for marketing companies. And we go run. So now we have 177, which is 200 minus the 23, because we had 200 clients in our list, 23 overlapped. 200 minus 23 is 177. So this is just the list of customers that were new, that never didn't come to the trade show. And of course, that one's not as useful because some companies will not guilt you. So in theory, we can flip it just to see what the difference looks like. And we go like this. And now we've got the 40 net new people that we've never sold anything to. So we can say, hey, we'd love to have you as a customer have an extra 15% off your first purchase. Can you tell I used to work with the marketing group at my old job? Making sure they had their data sets to do their spam emails and weekly. Database guy. Yeah, I didn't feel dirty at all. But so those are the set operations. What's kind of nifty, and I don't really have it set up for this, is you can actually combine multiple set operations one after another. So you can do a couple of unions and have an accept. You can have you can put parentheses in here so it does the first union, then does the accept. The thing about the set operations, they will go from left to right or top to bottom, depending on how you want to read it. So there's no, it's not like the and or, which there's an order of precedence where, do and, then or, then not. It'll always just go first query, second query, third query, fourth query, blah, 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 unless you put parentheses in. I have written a query and I have to dig for it, and I just don't think I've got it on me. At my old job, where I had 5 unions and an accept. So what this query did is, the way the software, trade secret or anything, kind of is, but it isn't. My NDA has expired anyways. So what would happen is when we sell software to a client, they picked a package level and then they could pick some add-ons. And all this stuff was in a database, and then I could run a single query that build up the feature set that they were allowed to have, and that would get put in the encrypted file, so it would turn the menus on and off and features and stuff like that. So the thing is that there was features coming from the base package, and then there was a set of features that would come in from what they called the accounting code, essentially the configuration past the base model. So you have, when you buy a car, you got the base model, and you got another model that has a little more things in it, and you got another model that has more things in it but takes something out. Software was the same way. So we had first query would pull the base features, second one pick the features that they picked on top of that, based on the version, right? So you had the base version, the pro version, the ultimate version, let's call it. But then you had another one past that, which were add-on modules that they could pick. So these add-on modules would turn on other features. So it would do union, 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 because now we're at, 3 queries deep. But then there was a list of features that were never allowed to go out to the public. And some of these features were in the old packages, and they wanted to make sure that these features were never turned on, usually for legal reasons. So right at the end, there was an accept. And the accept would pull the table saying, this list of features must never see the light of day. So it would build up the entire list and then subtract these features just to be safe. The query was from top to bottom was about a page and a half long. So it was about 125 lines of SQL, and it would run in a tenth of a second. It was really cool because the unions were very efficient because it would run actually each of the queries in. It'd run the first query and the second query at the same time, then do whatever, then run the next one and do whatever. So it was actually running queries in parallel, which was really cool. Um, so yeah, you can use this for more than just doing emails. You can do it for extracting data sets or data scientists like union operators because they liked seeing overlaps. Which cities have had more reports of Japanese ladybugs? Maybe they want to do a union of all the cities so that have reports of this. And you could run a couple of queries to extract some data from that. Or maybe you want all the cities except Ottawa because Ottawa's got a different pest control system, whatever. Um, it's some of the interesting things you can do with these basic sets. Your imagination's the limit, actually, what you can do with them. Um, but yeah, that's literally that operation. That was literally the topic for today. So I knew, as I said, it was going to be a short class, and the lab's really short too. It's 6 queries, and it's a couple of you write a union, then it tells you to rewrite it this way, and then rewrite it as a subquery. Because some of these things you can do as a subquery. Actually, I'll demonstrate this intersect as a subquery, so you guys have a better idea. Since I have a bit of time in the class, so if I go select email from clients, where email in select email from booth visits. Okay, 23. It's the exact same number. Um, is there a clear advantage to running it as a set operation versus a subquery? It's a use case. It depends on what you're trying to achieve. The thing is with the set operations, you can have queries that have multiple joins in it. From another query has multiple joins, but they're joining different things. So you can build two completely different data sets. And with MySQL, which this is a MySQL quirk, and it's one of and MariaDB in this case, but same difference. You can actually query multiple databases at the same time. So in theory, you could have a database with one complete data set that looks one way, and then you have another database with a data set that's completely built different, but you want to see records that match in both built on different queries. So that's what the union or the set operations, you're operating on two totally different queries that basically return roughly the same kind of stuff. And you want to just know the difference between database A and database B, or you want to know the difference between product configuration A and product configuration B, and the products are configured completely different. So yeah, you can do it with this, and we can emulate the accept also um, by literally going not in. Now, the other thing that is important to note is, let's just say I want to do operations with both the name and the email address. Does anybody in here have a shared email address with their significant other? That used to be really common back in the day, okay? Just saying. When you used to have dial-up internet and you used to get one email address for that one dial-up account and the whole family shared the same email address. Um, or sometimes, like my daughter and her partner do this. They have their own private email addresses, but they also have a combined email address where their bills go to, so they both get the bill. So they have a household email address. So their hydro bill goes to this email address. Their gas bill goes to this email address. Yeah. So it's the, or it's registered with their points accounts so that, the points all go to the same bin between the two of them. So it's just effective management of your stuff. But then sometimes you want to know that, oh, it's this email address, but it's a different name. Actually, this should be interesting. I never even tried this. Look at this, 177, totally different set of numbers. Um, because apparently, oh, actually, no, 177 is right. Um, so here's the issue. You can't do that here. If you want to do an accept on two columns, you have to find a clever way around that problem. And I'm actually going to return this to the way it was, and I'll show you guys how you would do it, and then you'll understand why it's so gross to emulate that. Okay, so I already demonstrated this one. So if I want to do the exact same thing here, okay, I can add the name here. That's cool. However, if I want to emulate being unique on both columns combined, one 177. What I'm doing here is I'm concatenating. You guys have learned about concatenation yet? You take string A, you glue string B to string A, you got a bigger string, concatenation. Okay, echo, you can cat with echo. But, yep, but you'll learn it in Python, which I think in Python's a plus. Um, in PHP, it's a period. Yes, no, plus is stupid. Think about it. String A plus string B equals longer string. You're not adding the strings, you're gluing them together. So PHP actually has an operator for concatenation. You're not adding two strings. Anyways, it just drives me nuts when I see that in other languages because I've been a PHP developer for like over 20 years. So PHP has an operator for concatenation. Databases have either functions or operators for concatenation. Postgres, it's double pipe. Double pipe is gluing things together. Don't know, but it works. No, they've got something else. Yeah, yeah, exactly. You can just list files. So what I'm doing here is I'm building a concatenated version of the fields, which looks like this. And I compare it to the concatenated version of that field on the other side. This is not efficient. Just saying. Um, it adds overhead to the query. Why? Because it has to concatenate every row on both queries before it even does the compare. It's gross. It'll work, but it's gross. So back in the day in MySQL and MariaDB, before they supported proper accept or intersect, this is how you did it. You did a subquery with a not in. Or you do a really weird join where you do a left join or right join, and then you add some weird parameters in your where clause to exclude the ones from one table. So it would give you the intersect by using a join. Um, yuck. But there's ways around it. The set operations are just more elegant. Um, that's something you'll probably hear as you progress in your IT career, the phrase elegant, which is basically, is there a nicer way to do this than the gross kludge that has been put in place? So you want to go for graceful and elegant, not baling wire, duct tape, and crazy glue as much as possible. Okay, so that's the end of today. I will be posting this. Actually, I've got time before I even leave this room, so I'll post the example right away so you guys have it at the start of the lab. This has almost everything you need for the lab. Do it. So an example of everything you need to do the lab. Honestly, I've had students do this lab in under 15 minutes. So Hey? Oh, it's up. So I'm going to hit the stop record button now, and I will post the example and the announcement, and then the recording will follow shortly.